Uh, I'm Siddharth, and as you all guys know, we have this Scala India community where we have Scala developers from across the nation, and it's an initiative to foster Scala in India, and in such a way that we have discussions around, we have speaker sessions, as well as we have Scala India Medium page where we tend to have blogs and all. And at the same time, it's great to have you all. And for future, also, in case you think of delivering a Scala session yourself or contributing article to Scala India Media page, just ping me up, and it would be great to have you. And today we have Vitthal among us. He's currently a staff software engineer at Walmart, and he today we'll talk about type-safe data engineering, and he has a lot to share, and can't wait to hear more from him. And I think Vittu can take it forward now. Uh, yeah, Vittu.
Sure. Thanks. Good afternoon, good evening, everyone. Thanks for joining in. I'm Vitthal Mirji. I'm from Mumbai, India, presently with Walmart. I would like to thank Scala India for organizing this. It feels privileged and I'm thrilled to share things which I have learned and then want to learn along. So I believe like teaching is another kind of learning. So yeah, this platform definitely helps me to grow and grow together again, right? So I would like to thank Scala India and especially Siddharth for organizing, sharing uh, this event across, and of course, all of you lovely audience, right? Without you guys, we cannot make it. So yeah, so let's get started. Today I'll talk about. I'm from data engineering background. I, I write ETL pipelines. I try to design them. Yeah, I like since beginning. I'm with Java and Scala. So along the way, I've done few Python things as well because, of course, predominantly data engineering also has that phase as well, right? The second part of the data engineering with Python, PySpark and stuff. So, yeah. So primarily today we'll talk about Scala. So people who are not from data engineering, definitely you will be comfortable because we'll talk more about Scala. And people from data engineering, you will feel comfortable because you will be able to align what I talk um, with respect to Scala, right? So yeah, so I'll get started. All right, so we'll set the premise like assume you are into a development, and then one fine day you will get a requirement saying that write an ETL pipeline, source some data, do some business transformation, and dump it somewhere. Like assume you have already done and assume there is a column drift, meaning like you have an extra column or you have a column which was present and now it is not available. Now you start this rollback someday in the afternoon or maybe in the night or worst case Friday night, right? So this silent drift of missing column or addition of column. So it was discovered only after your SLA dashboards have turned red and you started getting escalation emails, fix immediately and stuffs like that. So so this is the story. Like this usually happens. It's unavoidable or like how can we do it better, right? We will reframe this like what if these failure move towards left, like you saw this problem in runtime, How about if you see this failure at compile time? So what if these broken data pipelines did not at all start? Like you did not even deploy. Let's not go that far. You were not able to deploy because your CI did not accept this because the build failed, right? So that's the first part. And the second one is like, because you are dealing with data, so the effect here is, the pure value here is the output of your data. So, and because you are into large data pipeline, you are supposed to do many other things. Like, for example, you want to print logs to console, or you have Yarn and other resource managers. You want to log this, want to print on console. Let's assume you also want to log the start time and end time. These are the things which you are doing apart from your actual value. Like I sourced the data and then I did some transformations and I got on my output. So this is your usual mainstream pipeline. This logging and other steps are required for visibility. So now this is your orchestration. Like you are wrapped around these orchestrations. Your actual value is wrapped around these orchestration. So now there is a possibility that all these gets mixed up. So you will get a snack, like Indian snack bhel. So in your pipeline, and definitely all these things are messed up because of these mainstream and the side effects. So today we'll talk uh, like what are the things which we see as failure, but equally we will see them as a feature. Like we will feel happy about our failures, right? Because they did not create a big scene at runtime. How can we achieve this, right? So this one, you have seen this fragile Spark job. If you are into data engineering, you have seen like you are reading a Spark, you are reading a data source. Let's assume some CSV, and then again like you are doing an transformation here. You are filtering some records and then performing an action like count. And meanwhile, you are doing an audit logging. Like this is my batch ID, something like that, and then you are doing actual transformations here, like so you want to add a flag. um Now again you also want to do another um, task, like notify something. So you want to notify a HTTP server which will post some Slack notifications or some other notification that this pipeline has started, is expected to complete by this so and so. And then you are doing a data quality check if I have some rows or not. What ran actually produced some rows or not, something, some data quality checks. So this can be your business quality checks also, right? And then again you do audit logging that the DQ has passed, data quality has passed, and you are syncing like you are persisting the data to assume you are writing it to cloud. And again in the end you are doing audit logging, the job is finished, and again you are notifying some Slack or email or something. Now if you see these cross marks here, this is totally unfriendly because there is no schema enforcement, or like you have lost complete type safety. What do you have in CSV? Is it aligning with your data stewards, which who has given you an ER diagram or a Erwin model? Is it really aligning or not aligning? You need to check. I mean, like you will find out only at runtime. Again, like the audit insert, even if you do upsert, right, it's not idempotent, meaning like if you retry, there will be duplicates. I mean, like there will be unnecessary IO, a lot of resource, unmanaged things like those things. Uh, because Spark jobs are speculative, speculating meaning their lineage will form once again and then they'll start once again. So if you are hitting these API lot many times, this will breach rate limits, stuffs like that. So yeah, again the audit is the same problem. So this is very fragile job, right? Like there is no safety here. The even in prototypes we cannot write like this. Yeah. So non-idempotent schemas like without unique keys, even if you add unique keys, right? So retries, restarts are not at all safe. So semantics are not right. So this is your usual Spark job, which you we all write. We have started writing when we started learning and delivering some things at our workplace. So we started like writing like this. And then we also deployed such jobs. We also deployed in production, and then we went into debugging mode late night, sometimes Friday night. So, and then not just this, we have accepted such things. We have accepted and we have normalized such things. So, the schema drift, which was discovered late, dashboards read, weekend hot fixes, late night hot fixes, we accepted and normalized. All right. These side effects, the things which are not your mainstream, leaking into your pure values and creating problems, we again accepted that. All these wrappers, they are not enforcing you for pure values and safe values. Also, all these jobs mix with your input output logic. So, today, what we are going to do is we'll turn this pain into some correct promises. Um, we'll introduce compile gates. We'll introduce data contracts and some policies. We'll see how can we do that. We'll see builders. We'll totally paralyze these pipelines, right? Like we'll try to break their pattern of going into production. So we'll see what are effects and what are these thin virtual threads called fibers. We'll have some boundaries for different engines, and of course developer experience. Right? We must feel confident what we have done will never fail in production. Right? So that's it, and then definitely I am open for learning. So this will be the agenda today. We'll start with data contracts and policies, right? So the first mental model is we'll introduce some policies, right? So we have four policies. We'll see four policies, right? Exact, backward, forward, and full. So exact means you strict compatibility will immediately reject any extra fields, any mismatches, the order mismatch here and there. You straight away reject. Backward is like it's a evolution. You will allow extra fields in after transformations. Of course, we will reject type mismatches. We'll keep little flexibility, and then forward is like flexible compatibility, meaning like you will allow missing fields, field or order of fields also will allow. Type again will definitely reject them, and any extra fields also will reject. Full is like should not be used at anything goes. It's a escape hatch, right? So so this is a mental model. Like we prepare some logical parts here, like very low level design, right? So all these contract fields must be in output. All the must be in output, must match types. Kind of a mental model we'll prepare, and let's introduce these policies and we'll match with these contracts which our data stewards, data model and warehousing architects give. um, But this is the extended version. I just put a slide, so we'll go to the core principle, right? So we'll totally parallelize the API. Like you're seeing on the screen, there is a consumer data as a producer data. So it has two fields, ID and email, and ID, email, and age, right? So we want to introduce an confirmation or a evidence which will try to match exactly and then fail at compile time. Like this implicit thing or this um, I'll get into mechanism, but this thing will not even compile. So if you are trying to match exactly the producer and consumer, exact policy will fail according to our mental model or the logic which we have crafted. Now going to backward, like backward is like your transform data. The producer may add extra fields, like because you are transforming, you are deriving some edge, or you are doing a master data lookup and fetching the edge. So we are going to tolerate these things, and it's okay. So we will put the schema as backward and let it compile, right? So this is the principle. So what we are trying to do is we are totally stopping at compile time. We will not move forward if we are trying to match exactly. How do we achieve this, right? So how do we, so one second. So how do we achieve this? So the one of the beautiful concept of Scala is like you can take control of your program at compile time. Definitely, this is introduced in Scala 3. Scala 2 has libraries from type level organization called Magnolia and Shapeless. But what we are seeing on slide is especially Scala 3. We have inline functions and macros. So, what is an inline? So, I'll tell a little bit and then show you something. So inline is something which compiler replaces at call time with the method body at the call site. Like totally transparent, improved, inferred types. Like you are trying to rewrite, the compiler is trying to rewrite that and it replaces at compile time so that you get more granular level of visibility or a handler. Now that is inline, and then macros are the things which will generate and inspect these things. Like we have codes or reflection in Scala. So under the hood, so which will try to match these, and then we'll get that notification at compile time. So why do we care about this? Like we derive shapes and materialize the evidences. The out policy, out is like your transform data, and the in policy, the policy, the out data, and the input data. So if not compatible, we will abort the compilation with a difference. So that will be your compile failure. So this is about inline and macros. So how do these work, right? So again, coming back to the same thing, how do they work? So you define a shape. Shape is nothing but like records feed. So your case class with a generic type. So it will build your complete abstract tree. Now, what is abstract tree? Abstract tree is something like let me share my another screen and show you abstract. So I hope my IntelliJ idea is visible, right?
No, no, it's not visible. It's the slide.
Still slide.
Yeah, yes.
Now,
No, no. Yeah,
one second.
yeah,
Oh, sorry. Now,
yeah.
yeah,
Now you can see the entire.
right. So, what is abstract syntax tree, right? Like, assume you have a very big expression. Now we all know functional programming is nothing but a very big expression. Even you are spinning up a server, spinning up a huge data pipeline is just one big expression. Now let's assume you have this expression. Um, Now you want to calculate this, like you have number, you have sum, subtraction, multiplication, division, sine, cosine, and then you want to have a computation of sum of num2 with sum of again division with number 4, and then multiplication of number 2 with number 8, and then multiplied by sine of number 30. So they're very, very big expression, right? Now, we are talking about macros and inline. What compiler does is like you will rewrite this complete thing without these wrappers and inlining all these numbers with actual operations. Let me tell you what, right? So let me show you something. Right. So you're able to see this increment function, right? Yeah. And let me know if my screens are not in sync with what I'm talking. Okay. So
We can see.
yeah. So you have an increment function which accepts a value argument x and returns x plus 1, which is increment. Now what inline does? So if you declare this function as inline, I'll just change this function name. And when you do compile, what you are seeing here on the screen, this one. So because I'm calling this on 4 version 2. So I have a number 3, and then first I called on a normal function, a number, and the next I called on the increment function. Right? So this is the second version. So let's see what's happening here. So your a number plus 1. There is no function signature in while at compile. So there is no function signature, and then you are doing dot plus 1. This is again, all these functions are inbuilt in Scala. So what inline is doing, it is substituting by building a different tree. This totally is a syntax tree. So you are seeing this at compile time. So this total thing is a new tree which is built. So assume something like this. Your compiler is reviewing your code and then putting it in a right way. That's just an hypothetical assumption, but yeah, that for understanding purpose, understand that your compiler is helping you to fail fast, fail early, right? So when you do actual thing instead of the signature, right? So you get exposed to, you are being a handler to such things very early at compile time. Okay. Now what macro is, right? So I'll go to macros. So macro is something which will detect or like which will rewrite. So you again, like I am defined this first my macro as inline, and then these are type expressions. So this is syntax of macros. So this is my implementation of macro, right? So I will return the like a string which is of an expression, and this expression will return a string. So this is my macro. So it will accept arguments in number and string, and then they are changed to expressions. Expressions are nothing but again the the rewritten abstract syntax trees. And then how do you call this? Like you call this, and then what happens here is you say this string. So the entire string is written on your first macro. So you are replacing with actual values at compile time. It detects the expressions and directly replaces at compile time. So if you do this right, if you do this at directly in your code, then it compiles as well because it's just nothing but a rewritten code. So coming back to our this thing, so this is how macros and inline work. So uh, now coming back to our compile time. So the slide. So we define these abstract syntax trees dynamically to normalize. We will go deeper, right? We have fields like primitives, options, array. So the collections for recursive comparison because list of list of list trees. So that you need. So what macro does is macro compares your output with your content under a particular policy, and that is nothing but your evidence. If evidence is correct, then you will move ahead. Otherwise, abort. So that's the mechanism. So um, so this slide, I'll try to zoom in. Is the zoom visible, right? So how does your flow look like? So you developer writes type like defines policy, contract type, the source and the output records, and then you also write your ASTs like the evidences, and these are edges are for your next things like you have source data, not just case classes. We saw example one case class. So you may have CSV data, you may have Parquet data. So this is again an extension. Again sync. So this is a record, but this is a sync of your record. This is a source of your record. So all of these require your evidence. Evidence is nothing but a type class instance. So compiler must find and then it should confirm at compile. Right? So to uh, evidence to complete or like to go ahead, it needs the derivation